Welcome to RoRe Academy YouTube channel 2.0. Our new and improved channel is dedicated to showing you how things are put together, from concept to prototype. Here, we break down the art of designing, assembling, and testing real engineering systems, helping you understand the science and creativity behind innovation in power electronic-centric systems and devices in our 5-minute video clips. If you're into EVs or work with electric cars, you need to check this out. The AutoMaxi Ultra EV Diagnostic Scanner is seriously one of the best tools out there for deep-dive battery diagnostics and full system testing on electric and hybrid vehicles. It's fast, accurate, and super easy to use. Honestly, a total game-changer if you're serious about understanding your EV inside and out. So if you want to grab yours, just click the link in the video description below and check it out. The Tesla Model S, sleek, powerful, and one of the most advanced electric cars ever built. But what exactly makes this machine tick? Let's break down the three main components that define its performance and technology: the car body, the drive unit, and the battery pack. First, the car body. Made primarily from lightweight aluminum, it's designed for both strength and aerodynamics. Every curve and contour reduces drag, improving efficiency and range. Inside, Tesla combines minimalism with cutting-edge technology, from the massive touchscreen to its advanced autopilot sensors. The body isn't just about looks. It's a key part of the car's energy efficiency and safety. Next, the drive unit, the heart of Tesla's performance. This unit combines the electric motor, inverter, and gearbox into a single compact system. The result? Instant torque, lightning-fast acceleration, and near-silent operation. Depending on the model, the Tesla S can go from 0 to 60 miles per hour in as little as 2.1 seconds, faster than many supercars. And finally, the battery pack, the real powerhouse. It sits low beneath the floor, giving the car a low center of gravity for better handling. Inside are thousands of lithium-ion cells working together to deliver a range of up to 840 kilometers on a single charge. Tesla's thermal management system keeps the battery at the perfect temperature, ensuring both safety and longevity. The Tesla Model S battery pack is made up of an incredible 7,104 individual 1865 lithium-ion cells. These cells are not all connected in one massive assembly. Instead, the pack consists of 16 identical battery modules, making it easier to manage, cool, and maintain. Each module contains 444 cells, arranged in a 74 parallel and 6 series, 74P6S, configuration. This clever design allows Tesla to achieve the desired voltage, capacity, and thermal balance needed for high performance and long driving range. Through this modular approach, Tesla ensures that the battery pack delivers both power and reliability, while also simplifying manufacturing, testing, and serviceability. A true example of engineering excellence in electric vehicle design. Tesla uses 18,650 Li-ion cells manufactured by Panasonic for their Model S and Model X variants of cars. The battery cells used in the Tesla Model S are called 18650 cells, and here's what that name actually means. These cells are cylindrical in shape, and each one measures about 18 millimeters in diameter and 65 millimeters in height. So the name 18650 isn't random. It's a simple code that tells you exactly those dimensions. If we split the numbers into 3 parts, the first 2 digits, 18, represent the diameter in millimeters. The next 2 digits, 65, represent the height in millimeters. And the final digit, 0, tells us that the cell is cylindrical in shape. So whenever you hear 18650, you're hearing the cell's size and shape built right into its name: 18 millimeters wide, 65 millimeters tall, and cylindrical. It's a simple naming system, but it's what helps engineers around the world quickly identify and design with these cells, the tiny powerhouses that drive the Tesla Model S. Each 18650 cell inside the Tesla Model S might look small, but it's packed with a remarkable amount of energy. Let's break down what one of these tiny cylinders can actually do. It has a nominal voltage of about 3.66 volts, a capacity of 3.4 ampere-hours, and that gives it an energy content of roughly 12.4 watt-hours. That's about the same amount of energy it takes to power a 12-watt LED bulb for 1 hour. But what really makes this cell impressive are its energy densities. It has a volumetric energy density of around 755 watt-hours per liter, meaning it stores a lot of energy in a very small space. And its gravimetric energy density is about 254 watt-hours per kilogram, so for its weight, it delivers a powerful punch. Each cell weighs just 49 grams, yet when you multiply that by the thousands of cells inside a Tesla battery pack, you get the incredible range and performance that make the Model S one of the most advanced electric cars ever built. Tiny, light, and unbelievably efficient, each 18650 cell is a small piece of engineering brilliance that, when combined with thousands of others, powers the future of electric mobility. Now, each 18650 cell in the Tesla Model S has a nominal voltage of about 3.66 volts. That's great for a single cell, but not nearly enough to power a car. So, how do engineers increase the voltage? By connecting cells in series, end to end, just like stacking batteries in a flashlight. When you connect two cells in series, their voltages add up. So, instead of 3.66 volts, you now have 7.32 volts. And if you connect a third cell, the voltage rises again. 3.66 volts times 3 equals 10.98 volts. This is the basic principle behind every battery pack. By connecting multiple cells in series, Tesla can build up the high voltage levels needed to power the motors efficiently, while still using tiny, standardized cells. So, by simply linking more cells together, we can go from a few volts to hundreds of volts, turning small battery cells into the powerful energy source that drives the Tesla Model S. Inside each 18650 cell, there's a lot more happening than meets the eye. What looks like a simple metal cylinder is actually a highly engineered electrochemical system, carefully designed to store and release energy safely and efficiently. At the heart of the cell, we have two main components, the anode and the cathode. These are the positive and negative electrodes, and they're separated by a thin microporous separator, which prevents them from touching while still allowing ions to pass through during charging and discharging. At the top, we have the positive terminal and the positive tab, which connect the cell to the rest of the battery module. The entire assembly is enclosed within a metal case, usually made of steel or aluminum, providing both mechanical strength and protection. And at the base, there's a bottom insulator, which keeps the internal components electrically isolated from the outer casing, ensuring the cell operates safely under all conditions. All of these layers, the anode, separator, and cathode, are wound tightly together in what's called a jelly roll structure, maximizing the surface area and energy storage within that small cylindrical shell. So, even though the 18650 cell looks simple from the outside, its internal structure is a masterpiece of precision engineering, carefully designed to deliver high energy, high safety, and long-lasting performance in every Tesla battery pack. Each Tesla Model S battery module is made up of 444 individual lithium-ion cells, carefully connected to deliver both high energy and high power. These cells are arranged in what's called a 74P6S configuration. Let's break that down. The 74P means that 74 cells are connected in parallel, side by side, to form one group. When cells are connected in parallel, their voltages remain the same, but their capacities add up, allowing the battery to store more energy. So in total, you have 6 series groups, each containing 74 parallel connected cells, making up 444 cells per module. This smart combination of parallel and series connections allows Tesla to build battery modules that are not just powerful, but also efficient, safe, and perfectly balanced for the performance demands of the Model S. In a parallel connection, the voltage of the configuration remains the same as that of a single cell, but the capacity increases because the cells share the current load. Since each 18650 cell in the Tesla Model S has a nominal voltage of 3.66 volts, a 74P grouping, that is, 74 cells connected in parallel, also yields a total of 3.66 volts. Now, when we move to a series connection, things work a bit differently. Here, the positive terminal of one cell connects to the negative terminal of the next cell, and the voltages add up. So, when 6 of these 3.66-volt parallel groups are connected in series, the total voltage becomes 22 volts. Thank you so much for watching today's video and exploring how the Tesla Model S battery module is put together, while highlighting its critical components. Remember, here at RoRe Academy YouTube channel 2.0 you watch, learn, and understand how to prototype. See you in the next video. If you found this video insightful, don't forget to like, subscribe, turn on notifications, comment, and share, so you never miss our next deep dive into the world of technology and innovation.